Contactors are used in the control circuits to connect and disconnect the consumer's power circuits. Contactors are actually the link between control and power circuits. These equipments consist of two E-shaped cores, one of which is fixed and the other is mobile. Between these two cores, there is a magnetic coil or simpage. When it is energized, the moving core moves towards the fixed core and causes a number of contacts to close or open. When the bobbin power is cut off, the moving core is returned to its previous state by a spring and the circuit is cut off. Contactors are made in AC and DC types. In AC types, since the bobbin is electrified using AC voltage, the amount of voltage applied to it and as a result the current passing through it is changing. The variability of the current causes the variability of the magnetic flux created inside the core, and as a result, the force acting on the moving core, which is directly related to the square of the magnetic flux created in the core, will be variable. The variability of this force causes the moving core to start disconnecting and connecting and vibrating. To solve this problem, a shortened connection ring is used on the core. As a result of changing the magnetic flux of the core, a magnetic flux is created inside this ring, which has a phase difference with the initial flux. In this way, when the magnetic flux of the core is zero, the magnetic flux of the ring is maximum, and therefore this ring causes a relatively constant magnetic flux to pass through the core, and as a result, the slip of the core is reduced to a great extent. Contactors usually have 3 input terminals and 3 output terminals to connect the power circuit. According to the IEC standard, these terminals are marked on the contactor with numbers 1 to 6. And terminals 1, 3 and 5 are inputs and terminals 2, 4 and 6 are outputs of the power circuit. In other standards such as NEMA, input terminals may be marked with 1L, 2L and 3L and output terminals 1T, 2T and 3T. On the contactors, 2 or 3 other terminals may be considered to connect the two ends of the contactor coil to the circuit. These terminals may be marked with the letters 1A, 2A or 1B and 2B in the IEC standard. In addition to the main contacts that are used in the power circuit, contactors usually have one or more auxiliary contacts that are used in the control circuits. These contacts are divided into two types, open normally and close normally, depending on how they function. Open normally contacts are open in normal state and are closed with contactor operation, while closed normally contacts are closed in normal state and open after contactor is connected. By using these two types of contacts, it is possible to design and execute all kinds of complex control circuits. According to the standards, all auxiliary contacts of the contactor must be connected to one axis so that when the contactor is disconnected or connected, no two open and closed contacts are closed at the same time. According to the IEC standard, the terminals of these contacts are identified by using two numbers. The first number indicates the contact number and the second number indicates the contact type, i.e., whether it is open or closed. According to this standard, if the second number is 1 or 2, the contact is normally closed, and if this number is 3 or 4, the contact is normally open. For example, if the terminals on the contactor are marked with numbers 23 and 24, it means that these terminals are normally open and are related to the second contact of the contactor. Usually, contactors are considered to be able to increase the number of auxiliary contacts. This increase is done through additional blades that are installed on the contactor or next to it. Contactors are made in different powers, sizes and for different applications, which should be taken into account when choosing them. The most important specifications of a contactor according to the IEC standard are as follows. 1. Insulation voltage. The voltage for which the contactor insulation is designed and insulation tests have been performed on it with this voltage level. 2. Maximum working voltage. It is the voltage at which the contactor operating characteristics such as its lifespan are provided by the manufacturer based on working at this voltage. 3. Nominal coil voltage. It is the nominal voltage in which the contactor coil is designed to work. 4. Rated working current. It is a current that is provided by the manufacturer considering the contactor's operation specifications and the contactor is designed for continuous operation in that current. 5. Nominal thermal current. It is the current that the contactor can withstand in the closed state, in the open air, for 8 hours without its temperature exceeding the amount mentioned in the standards. 6. Working group. The IEC standard divides contactors into different categories depending on the application and the place of use, which includes both AC and DC contactors. The most important of these groups in AC voltages are 3AC, 4AC and 11AC groups. 3AC group is used for disconnecting and connecting caged induction motors and they are designed to disconnect the nominal current of the motor. This group of contactors can withstand the starting current of the motor. The 4AC group is also used for squirrel cage induction motors, with the difference that it is designed for severe disconnection and connection. This group is used for the applications of changing the engine speed, engine braking and engine shutdown in locked rotor mode. In working group 11AC, there are contactors that should only be used in command circuits and do not have power contacts. In addition to the mentioned groups, there are other groups that are used to disconnect and connect the current of transformers, capacitor banks, etc. For information about these groups, you can refer to the file below. '7. Rated power. It is the maximum power that the contactor can pass and is usually written on it according to the contactor grouping and the voltage level. Today, contactors may be designed for specific purposes. One of these purposes is the disconnection of capacitors. When connecting the capacitors to the circuit, a large volume current is drawn from the network, which can reach 100 times the rated current of the capacitor. This current has a high frequency of about 3 to 15 kHz and it exists for a time of about a few milliseconds and then it fades. In the contactors that are designed to interrupt this kind of currents, a resistance branch is used in parallel with each contact. At the moment of connection, this branch is connected first, and after controlling the current, the main contacts of the contactor are closed. After connecting the main contacts, the resistance branch is removed from the circuit. This type of contactors are used in capacitor banks that are installed in the network to improve the power factor.